Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized, easy-to-digest pieces.
Today, we're diving into the high-stakes world of finance and a problem that's giving regulators a massive headache: artificial intelligence, specifically AI that can act on its own.
Right, we're talking about Agentic AI, systems that don't just chat with you, but can actually execute trades, manage portfolios, and make financial decisions autonomously. It sounds like the future, but there's a fundamental clash at the heart of it.
The clash is this. The AI systems we're all familiar with, like the ones that power chatbots, are what we call probabilistic. A better word for it is they are professional guessers. They generate responses that are statistically likely to be correct.
It's like asking a brilliant, creative writer to do your taxes. They might give you a beautifully written, very convincing tax return, but you have no guarantee that the numbers are mathematically correct.
Exactly. And in finance, you can't have probably correct. A single wrong guess, a single algorithmic deviation, could lead to catastrophic losses. We've seen it before, like the Knight Capital incident in 2012, where a glitch lost a company $440 million in 45 minutes.
Because of events like that, regulators have very strict rules. One is called the Market Access Rule, which basically says financial firms must have direct and exclusive control over their trading systems. You can't tell a regulator, well, our AI is compliant 99.9% of the time. That 0.1% is a disaster waiting to happen.
So companies have tried to solve this by putting up AI guardrails. The problem is most of these guardrails are just another AI watching the first AI. It's like hiring that same creative writer to double-check the taxes. You've just added another layer of guessing.
But a new paper titled Type-Checked Compliance proposes a radically different solution. Instead of trying to control a guessing machine with another guessing machine, it brings in the absolute certainty of mathematical proof.
This is where it gets really cool. The system is called the Lean Agent Protocol, and here's how it works. First, a compliance officer at a bank writes down a rule in plain English. For example, do not execute trades that exceed 10% of the firm's available daily capital.
Simple enough. But then a special kind of AI called Aristotle gets to work. Aristotle is a neuro-symbolic model, which means it combines the language understanding of a chatbot with the cold, hard logic of a classical computer. It translates that English rule into a formal mathematical language called Lean 4.
Think of Lean 4 as a language of pure logic. Once that rule is translated, it's not a suggestion anymore. It's an axiom. It's a mathematical law that is set in stone within the system. This all happens behind the scenes, before any trading even begins.
Okay, so the laws are written. Now let's go to the live environment. A trading AI, doing its thing, decides it wants to execute a big trade, say buying 50,000 shares of a tech company. But before that order can go to the market, the Lean Agent Protocol intercepts it.
And it turns the proposed trade into a mathematical question, a conjecture. The question is, does this action of buying 50,000 shares satisfy all the mathematical laws we have on the books?
And who answers the question? Not another guessing AI. The core engine of Lean 4, called the kernel, steps in. The kernel is a mathematical proof checker. It doesn't estimate or guess. It returns a simple binary answer, true or false, yes or no.
And it does this with incredible speed. The paper cites tests showing this kind of check takes about 5 microseconds. That's 5 millionths of a second. It's so fast, it's basically instantaneous.
So if the proof is verified, if the answer is true, the trade is instantly allowed and goes through. But if the kernel cannot prove that the trade follows the rules, if the answer is false, the trade is definitively blocked. There's zero chance for a non-compliant trade to slip through. It's a level of certainty the paper calls cryptographic.
But it gets even better. In many countries, there are right-to-explanation laws. If an algorithm denies you a loan, for example, it has to tell you why in a way you can understand. A typical AI might struggle with that, but this system shines.
Because if a trade is blocked, the system knows exactly which mathematical law it broke. It can then perform a kind of reverse translation, taking that formal logic error and turning it back into plain English for an audit trail or a compliance officer.
So the output isn't just access denied, it's trade blocked because it violates the axiom trade value must be less than available capital. It provides a perfect, clear, and unhallucinated explanation every single time.
So what this paper is proposing is a way to get the best of both worlds. You can use the powerful, flexible, and adaptive new AI agents to come up with smart financial strategies, but you put a completely deterministic, mathematically proven gateway between their thinking and their doing.
It separates the probabilistic "should we do this" from the deterministic "can we do this." This lean agent protocol acts as an infallible bouncer at the door of the financial market, checking every single action against a set of unbreakable mathematical rules.
It's not just a better guardrail, it's a whole new paradigm. It's a fence built not out of suggestions or probabilities, but out of pure, verifiable, lightning-fast logic.
And it might just be the key to letting AI revolutionize finance safely and responsibly. That's all the time we have today. Thanks for tuning in to Daily Papers.